My name is Rohit Shinde, and we are explaining a boost converter design using a Simulink. It is presented by Srirang Pawar, Rohit Shinde, Gurjit Sandhu, Apaya Sheikh under the guidance of Dr. G. Vijayakumar. Boost converter use a DC power source inductor to store energy and smooth current, then MOSFET switch to control the power transfer via the PWM means pulse width modulation. PWM blocks generate a power control for a switching, then diode allows one-way current flow, then capacitor gives a smooth and stable output voltage, then resistive load to consume the circuit power, then a voltage sensor and current sensor to measure input and output voltage, then scope and display to show the output waveform, and last we use a power guide to manage simulation and analysis. Then boost converter MATLAB simulation. In Simulink, the circuit built with this component. When switch is on, inductor store energy, and when switch is off, inductor release energy, boosting with the DC supply. Then capacitor keeps the stable output, and the waveform shows the higher DC voltage at the output. Next point, explain Apiyashik.
Hello everyone, my name is Sheikh Afia. Let's start our simulation. Firstly, we take DC voltage source. The value of DC source is 20 volt, and nextly we take one means series RLC branch. The value of series RLC branch, in series RLC branch we take inductance, and the value of inductance is 0.003, and nextly we take diode, and the value of diode is 0 point, the resistance is 0.001, and secondly we take one capacitor. The capacitor value is 0.006, and also we take one resistance. The value of resistance is 50 ohm, and next we take two voltage sources, this and this one, and nextly we take one pulse generator. The time period is 1 by 2000, and pulse weight is 50. Also we take one display and one scope. Thank you.
Hello guys, I'm Ms. Gurjeet and I will explain the simulation. So first and foremost, we will connect the DC voltage source to our series RLC branch. Then afterwards, it will be connected to our diode, and IGBT will be also connected to our diode. The IGBT will be also connected to the pulse generator. Then afterwards, we will connect our capacitor and resistor too with the connection of the diode. So first and foremost, we will connect our resistance, then afterwards capacitance. After connecting them, we will interconnect the DC voltage source and all of the source so that we will get the output. Okay, so now we will connect our capacitor over here. We will complete our connections, and the remaining IGBT connection will be also connected by the DC source with the DC source. Then afterwards, we will connect the positive side of our voltage source to the positive side of our DC voltage source with the positive side like this. And afterwards, the negative side will be connected to the negative side of our DC voltage source. Okay. So now we will connect this voltage sources also, that is the voltage measurement source, to our resistor. And here also. Okay. So now we will connect the display and the screen too. So first and foremost, we will take this voltage source, voltage measurement to our scope, second input, and the voltage here will be connected to this, and the display will be also connected over here. So this is the final simulation of us, and here we have used the continuous. So after a simulation, I will explain why we have connected the sources. So first and foremost, we have taken the DC voltage source. It is the input supply. It can be a battery, a solar PV panel, or otherwise, or any DC supply too. We will connect it because it will boost the converter main purpose, and it will step up the DC input to the higher DC output. Then afterwards, here we have connected a pulse generator. It is not a power source but a control signal source. It generates a PWM signal which decides when the IGBT is on or off, and we need it because it controls the duty cycle. Rather than that, output voltage of the boost converter is directly related to the uh, duty cycle, and higher duty cycle is the higher output voltage. Then afterwards, we have connected the IGBT over here. It is the switching device that alternates between on and off state. Then when the in off state, the current flows through inductor. It stores energy, and in off state, inductor releases energy. Okay. So afterwards, we have used here series RLC branch. The inductor is the key element in the boost converter. It stores energy when switch is on, then it releases the energy when the load switch is in off position. Then afterwards, here we have used a diode. Here we have used a diode. It provides a freewheeling path for the current when the switch turns off, and afterwards prevents capacitor from discharging back to the source. Then here we have used a capacitor act as an energy source element in the output. It also smooths the pulsating voltage coming from the inductor and the diode. Then afterwards we have used a resistor which represents the actual load, that is the bulb, motor, or any electronic gadget. It converts electrical energy into a useful work. Here we have used the voltage measurement sources from where we can utilize the voltage, and here we have used a scope in which, because of which we will be able to measure the device simulation. Then afterwards, here is the display in which utilize the we will get the power and we will utilize it. It will show the how much power we have given to the circuitry simulation. So overall working of this simulation is that input DC source gives power, then afterwards pulse generator converts switching, then pulse generator converts switching, inductor stores and release the energy, diode ensure one-way current flow, capacitor and resistor provide smooth and usage of DC output. Scope let you see the result.
Hello, my name is Shirang Pawar, and I am from third year electrical engineering. Our topic is about the boost converter simulation using the MATLAB, and I am here to explain the output of the our simulation. So here we can see the circuit, and I will explain the all about the outputs, about display, and about the scope, also waveform about the circuit. So this is our circuit of the boost converter. So first of all, here we apply the DC input voltage. So we will check this value. So we have applied the 20 volt of the DC input voltage. So the most important thing about the circuit is that when the switch is on, the inductor act as a charging, and when the switch is off, the inductor releases the energy. So thus, when the DC input voltage plus the energy released by the inductor both adds up and gets the boosted. The boost converter boosts, or it is also known as the step up for the DC voltage. It steps up the DC input voltage and gives an step up output of the DC voltage. So when the output of the step up DC voltage by the boost converter is then given to the output, and here the voltage is measured, and here it displays in applied in the circuit, the display shows the value of the output voltage, which is 39.21, which is approximately double of the input voltage. It is because when the here we applied the pulse generator having the 1 by 2000 with the frequency of the time period of the pulse generator is 0.0005, and the pulse width or the duty cycle is 0.5%, so means half percent. Then here is a scope. So scope displays the waveform of the our output of the boosted DC voltage. And here is the spike at the starting of the out wave. So the spike can be reduced by some modifications in the circuit, and we will do it necessarily. But this we get the output of the output voltage, which is boosted. And here is the constant 40-volt line. And just at the starting, there is a spike, which will be reduced by us with certain modifications in the circuit. So this was all about the circuit uh, input output parameters. Thank you.